Hi class, and welcome to Module 4, Part 1, where we're going to start talking about hypothesis testing. Our objectives today are to define hypothesis testing, identify the null and alternative hypothesis, find the test statistic with and without knowing your standard deviation, sigma, make a decision using the p-value method, and make a decision using the critical value method. Okay. So what is hypothesis testing? A hypothesis test is a statistical test that is used to determine whether there's enough evidence in a sample of data to infer that a certain condition is true for the entire population. So a good example here, I'll make this a little bit bigger for you because there's a lot of words on this. Is normal body temperature really 98.6 degrees Fahrenheit? So we always see all those commercials. I think there was a gum commercial actually with that. So is that true? So consider the population of many adults. A researcher hypothesized that the average adult body temperature is lower than the often advertised 98.6 degrees Fahrenheit. That is, the researcher wants to answer the question, is the average adult body temperature 98.6 degrees, or is it lower? So to answer his research question, the researcher starts by assuming that the average adult body temperature was 98.6 degrees Fahrenheit. Then, the researcher went out and tried to find evidence that refutes his initial assumption. In doing so, he selects a random sample of 130 adults. The average body temperature of the 130 sampled adults is 98.25 degrees. Then, the researcher uses the data he collected to make a decision about his initial assumption. It is either likely or unlikely that the researcher would collect the evidence he did given his initial assumption that the average adult body temperature is 98.6 degrees. If it is likely, then the researcher does not reject his initial assumption that the average adult body temperature is 98.6 degrees. There is not enough evidence to do so otherwise. If it is unlikely, then either the researcher's initial assumption is correct and he experienced a very unusual event, or the researcher's initial assumption is incorrect. In statistics, we generally don't make claims that require us to believe that a very unusual event occurred. That is, in the practice of statistics, if the evidence, so your data, was collected is unlikely in light of the initial assumption, then we reject our initial assumption. Okay. So a hypothesis test examines two opposing hypotheses about a population. You have your null hypothesis and you have the alternative hypothesis. So your null hypothesis is the default position or status quo. Another way of looking at it is this is always the accepted fact. So looking back at that last example with the 98.6, that is the accepted fact. Okay. Usually the null hypothesis is a statement of no effect or no difference, and it is denoted by H sub 0. So that's really important that we have the notation correct, okay, because we're going to be using that a lot. So again, that's denoted by H sub 0. The alternate, and just some simple examples of some null hypothesis. So kind of like what I talked about, it is always the accepted fact. So for example, DNA is shaped like a double helix. That's an example of a null hypothesis. Or there are 8 planets in the solar system. Sorry, Pluto. Okay. So how do I state a null hypothesis? With word problems, you are looking to find a fact that is nullifiable, so something that you can reject. And we're going to get into that with the next example on how to write this stuff. Okay. So the next thing I want to talk about, though, is your alternative hypothesis is the statement you want to be able to conclude is true. Or in other words, it's what the researcher is proposing might happen. So this is either denoted by H sub A or H sub 1. I would say the most time I see it as H sub 1, but completely depending on what text you're looking at. And the alternative hypothesis could be not equal to, it could be less than or greater than the null hypothesis. Okay, and we'll get into that in just a second. If I looked at my last example on the slide with the temperature of the body, our null hypothesis is that the mean body temperature is 98.6 degrees. And then the alternative hypothesis was that the temperature was lower than 98.6 degrees. So let's do a little example. How do we actually write or state our null hypothesis? So it is an accepted fact, key word, that the ethanol boils at 173.1 degrees Fahrenheit. You have a theory that ethanol actually has a different boiling point of over 174 degrees. Give the null and alternative hypothesis. So first thing I'm going to do is just kind of write it out. So my null, remember that's kind of like your accepted fact. Well, ethanol boils at 173.1. The alternate, okay, would be ethanol boils at over 174. Okay, so that's great. We expressed it in words, but we need to convert this to math. So that's why that notation is so important. So remember your null, that's going to be my H sub 0. So again, and I'm going to be looking at the mean. So mu is equal to 173.1 degrees Fahrenheit. So that's how I write it in math terms. Now I'm going to do the alternative. So I'm going to use H sub 1. And I'm going to say the mu, because again, I can only use not equal to, less than, or greater than. So I'm going to say the mu is greater than 173.1. Because again, I'm going based off my mean. So that's how you write it. So again, if it helps to write it in words, then write it in math, or you can just skip ahead right to the mathematical notation, but that's how we're looking at it, and this is going to be the key thing right here. Okay, so here's another example. So again, I would like you guys to pause it here and try it out for yourself. Welcome back. Okay, so let's see how we did. A generic brand of the antihistamine, diphenhydramine, markets a capsule with a 50 milligram dose. The manufacturer is worried that the machine that fills the capsule has come out of calibration and is no longer creating capsules with the appropriate dosage. Give the null and alternative hypothesis. So this one's a little bit different because we're really only given one piece of information, and that is this right here, that they market a capsule with a 50 milligram dosage. Okay, so that is going to be my accepted fact. So that gives me my null. Okay, so H sub 0, my mu is equal to 50 milligrams. Okay, now let's look at the next part. So what would be my alternative? So they're telling us the manufacturer is worried that the machine fills a capsule, has come out of calibration, and is no longer doing the appropriate dosage. So therefore, my alternative, H sub 1, would that be mu does not equal 50 milligrams. Okay, and that's all there is to it. So you have to read the problem and see, do it for that, no, or the alternative hypothesis. Am I saying, is it not equal to, less than, or greater than? Okay, so here's a nice little summary here. So your null and alternative properties. H sub 0, remember that is your null, is the assumption, status quo, nothing new, accepted fact. It is assumed to be true. It's a given. Negation of the research question. Negation means opposite. And always contains an equality, equals, less than or equal to, or greater than or equal to. Your H sub A or H sub 1, that's your alternative properties. This is a rejection of an assumption, so of the accepted fact. A rejection of the assumption or the given. Research question to be proven. And it does not contain an equality. So that either means it does not equal, it's less than, or greater than. Okay, using the last property, we can logically derive the possible null alternative pairs. So you can either have H sub 0 is equal, is less than or equal, or greater than or equal to. And if you're looking at, that was the null. And if you're looking at the alternative, H sub A or H sub 1, it is either does not equal, it is less than, or is greater than. In opposition, and it's always in opposition to each other, cannot both be true. So if I use equal for my null, then I use does not equal for my alternative. If I use less than or equal to for the null, I will use greater than for the alternative. And if I use greater than or equal to for my null, then I have to use less than for my alternative. Okay, so this right here is very important. It's always in opposition to each other, cannot be true. So if you want to on your notes, box it. These two go together, these two go together, and these two go together here. Okay, so let's do some steps. So the first three steps are identifying the null and alternative hypothesis and writing them in symbols. So that's what we did on those last two examples, okay? So identify the claim to be tested, give symbolic form that must be true when the original claim is false, and identify the null and alternative hypothesis. So that's our first big step. Those are the first three. The next thing we want to do is select your significance level. That's your alpha. So we talked about that in Module 3. Your alpha, remember, was 1 minus your confidence interval divided by 100. For our purposes, we're always just going to stick with a 95% confidence. So if I actually computed alpha, 1 minus 95 over 100, I would get 0.05. So we are always going to just stick with that 95% confidence. Okay. Step 5, we want to compute the test statistic. So is it a Z or a T statistic? Remember, if our standard deviation is known for the population, your sigma, that is a Z. If it is unknown, we use a T. And then step 6, we're going to find the values. So either we're going to use the p-value method or the critical value method, and we'll get into that in just a second. And then we're going to make a decision based on the method. So are we going to reject it or accept? And then restate decision in non-technical terms. So that would be if someone wanted to read your research and they don't know a lot about math, you want to be able to write it so they can understand it. Okay, so how do I calculate the test statistic? So if we know sigma, then we're going to use the Z like we talked about. So that would be x bar minus mu divided by the standard deviation divided by the square root of n. And remember, n is your population size. If sigma is unknown, we use the t. So your t is again, that's your x bar minus mu all over s divided by square root of n. And remember, s is just your sample standard deviation, and sigma is your population standard deviation. Okay. In most cases, we will be using the second formula to calculate the statistic. Also, mu is found in the null hypothesis. So, important things there to make sure that you underline or highlight. So, mu is found in the null hypothesis. And for the most part, we'll be using this right here. Okay. So, let's look at this first example. So, the author obtained times of sleep for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times in hours are listed below. Here are the unrounded statistics for this sample. So n is 12, so that was our sample size. Our sample mean was 6.833333 hours. Our sample standard deviation was 1.99240984 hours. A common recommendation is that adults should sleep between 7 and 9 hours each night. Wouldn't that be great? Test the claim that the mean amount of sleep for adults is less than 7 hours using a 0.05 significance level. Okay, so steps 1 through 3. This is give the null and alternative hypothesis. Okay, well, let's look. We want to test, so I'm the researcher. I'm testing the claim that the mean amount of sleep is less than 7. Okay, well, then what I'm going to assume then, my null is going to be, whoops, don't want to put the equal there. Okay, so I'm going to assume my mean is 7. Okay, and my alternative is that it is less than 7. So that's steps 1 through 3. So I know it's like, oh, steps 1 through 3, 3 steps. That's just what you're doing here. Okay, so the next part is give my significance level. That is your alpha. So alpha is equal to 0.05. And then do I calculate this test statistic? So is it a Z or a T? Well, again, it's going to be a T because sigma is unknown. So we're going to go in here. So again, I'm just going to use, just go over here. So since it isn't, I'm using this equation right here. Okay. And again, you'll be given this stuff here, but if I was right, so 6.83 minus 7 all over 1.99 divided by the square root of 12. Now with yours, if you're doing your deliverable, you'll actually have a lot of these values in your Excel, so you won't have to at least worry about that. But if I was going to plug this in, let's just make sure we know how to do it. If I had those numbers in there, I would use those. Well, let's just, actually, I'm going to put them in. So let's just say, and just abbreviate, so I have 6.83, I have 7, I have 1.99, and I have 12. So let's just say I have this information in here. So just to practice that self-referencing. So I'm going to do equals. Now, again, you're going to have to be really careful with your order of operations. So the first thing I need to do is I need to put this first part in parentheses. So this minus this, okay? And I'm dividing it by this number here divided by the square root of this, and enter. Okay, so I get negative 0.02466